Hi, good afternoon. This is Mr. Cassidy, and today we are covering Chapter 1, Lesson 5 of Big Ideas IM1 curriculum, Rewriting Equations and Formulas. So let's get started. First, we're going to begin with a quick review of Chapter 1, Lesson 4. So go ahead and solve these. On problem 1, now do remember that some of these require two answers. So I'm going to go ahead and start. On problem 1, remember to break the x out of the bars. That's like a force field. Once we want to break it, we need to write two cases, case 1 and case 2. We're finding the two numbers that their distance is 15 from 0. And we do that by doing case 1 is positive and case 2 is negative. Those are our two answers, and that's it. Awesome. On problem 2, go ahead and solve. Okay, you should have, before you do anything to solve, we already have the absolute value isolated, so we just need to write our two cases. I'm going to write case 1, x minus 7 equals 18. And I go ahead and write case 2 right away, x minus 7 equals negative 18, because a negative 18, if it was in these bars, would equal a positive 18. Okay, go ahead and solve for each of the cases by adding 7. And we get x equals 25 on the first case. On the second case, we get plus 7, and we get x is equal to a negative 11. So we can write it like this. Negative 11, comma 25 is our solution set. Okay, go ahead and move on to problem 3. All right, what you should have done is first isolate the absolute value. We do that because we treat it like a force field. We have to remove everything else but that absolute value bars and everything inside it. We don't touch anything in the prison yet. So we divide by 4. That's our first step. That leaves me with absolute value of x minus 2 is equal to a positive 3. Now I can break him free of the prison and get my two cases. X minus 2 is equal to positive case. X minus 2 is equal to negative case. Great. Now I solve for x in each case. I'm going to go ahead and add 2 to both sides here to inverse that. And I get x is equal to 5. Here I'm going to do plus 2, and I get x is equal to a negative 1. My solution set is negative 1, comma 5. Okay, go ahead and try problem 4. Okay, once again, we're going to use inverse operations. You should have first used inverse operations in order to isolate the absolute value bars, and we work outside in, so we're going to work furthest from x by subtracting 1. What I get is 3 times the absolute value of 2x. Remember, when a 3 is smushed up here, it's like a parentheses, it's multiplying, equals 18. Now I'm going to divide by the 3 to get absolute value of 2x is equal to 6. Now I can break him free from his prison and do my two cases. 2x is equal to a positive 6, case 1. Case 2, I always sort of draw this line here, 2x equals negative 6. Now I can solve for x in each case. I would do that by dividing by 2 and getting x is equal to 3. And here I would divide by 2 and get x is equal to negative 3. All right, my solution set, negative 3, comma 3. All right. So from here, final problem here, what I want you to decide is A, B, or C. Which is the option to choose here? Is this a no solution problem? Is this a one solution problem? Or is it a two solution problem? So up till now, we've had two solution problems. So which of these options is it? I guess option D could be infinite solutions. However, that's not going to work here, so we can cross that out. All right, so with that said, let's go ahead and solve. You should have chosen A, B, or C. I would divide both sides by a negative 4 in order to isolate my bars. I get absolute value of x minus 7 is equal to negative 9, And what I see is an absolute value equals a negative. But the absolute value creates only positive numbers, so it can only be a positive number. In this case, we get no solution, A, because the absolute value, whatever is in here, no matter what, imagine it was a -2, the bars would make it positive, so we can't ever get a -9 as our answer. So A, no solution. You might be wondering, when is it one solution? Well, from our last video, you might remember that would be when we have the absolute value of x equals 0, or whatever's inside the bars, because there's only one number that's 0 away from 0, and that is, well, whatever you solve for x here. But only when it's equal to 0, it's one solution. Two solutions are the normal cases for all other positive numbers. Now, our lesson for today. On page 24 of your journal, you can follow along. We're going to take a quick look at the formula for Celsius. Celsius equals 5/9 times the quantity Fahrenheit minus 32. And as you guys may be familiar with, countries in Europe and most of the world use Celsius. And then there's us. We use Fahrenheit. Us, US, right there. Why? I don't know. It's like the difference between the metric and the standard system. We just do things our own way, I guess. Well, this may be useful in many cases. Since other countries of the world use Celsius, and you're so used to thinking in Fahrenheit, let's say we wanted to figure out what a human's average temperature is in Celsius, what doctors all over the world probably measure and think of as a human's normal body temperature. Well, what you would do is you would put in human body temperature here, 98.6, and we would solve from the inside out using PEMDAS to find out the Celsius. So let's go and do that. First, I would simplify inside parentheses, and I would get 98.6 minus 32 is 66.6. Boy, that's an interesting number. And then I'm going to multiply that. So right now, my formula looks like the Celsius is 5/9 times 66.6. And to be honest, I'm probably going to use a calculator on this, and I would expect you to do the same. So I would do 66.6 times 5 divided by 9. I'm going to pull up my calculator in a side window. I know you won't be able to see it, but that's how I would solve. Times 5 divided by 9. And I get 37 degrees. Exactly. So Celsius, that all doctors measure, they look at 37 degrees as the human body temperature when you're healthy. So go ahead and solve if Fahrenheit today is a whopping 112 degrees Fahrenheit. It may be hotter later today. And today is Monday. I'm recording the day before you guys are doing this lesson. So go ahead and plug in 112 degrees and find the Celsius that other people around the world would use. Okay, what you should have done is done Celsius equals 5/9 times the quantity 112 minus 32. From there, you would do Celsius equals 5/9 times 112 minus 32 is, what is that, 80? Okay. And then from there, you might use a calculator. You're going to do 5/9 times 80 over 1, or you might go 5 times 80 divided by 9. I'm going to go ahead and pull that on a calculator again. And I get 5 times 80 divided by 9 is 44.4. Celsius equals 44.4, repeating. We use this little bar to show a repeating decimal, degrees. Wow, that's pretty hot. I'm happy I'm inside right now. Hey, now the lesson does start just by giving us formulas and having us plug in numbers, but there's another reason for talking about formulas here. So when I traveled in Europe about, 8 years ago, we had my infant son. He was like 1 year old, and he got a fever. And we went out to the local drugstore and got a thermometer, measured his temperature, and it was something like, 39 degrees. It was in Celsius. And we were like, my goodness, what does that even mean in Fahrenheit? Now, there is a way we could solve that. Having the formula, we would just do 39 equals 5 ninths F minus 32. And we'd solve for it the way we would solve for x. We would undo first the fraction, then add 32. But that is a lot of steps. And if you have to do the same conversion over and over, let's say you keep measuring people's temperatures. So let's say you go abroad and you're measuring people's temperature and people are like 38.7, 30, 36, somebody's a little low. And you're like, this is getting annoying because I keep having to solve for a variable. Well, what we can do is we can rearrange an equation. And I'm just saying all this to introduce our next idea. That is rearranging a literal equation. So since the main equation is c equals 5 ninths times f minus 32, and if we know that we are always going to have Celsius, but we want the Fahrenheit, so like the conversion, the formula that people would use in other parts of the world if they come to America. Well, here's what we would want to do. We want to do the opposites until we solve for f. So for a problem like this, I would first get rid of this fraction by multiplying both sides by 9 over 5. And I would multiply this side by 9 over 5. And just follow along here so you understand the main steps. That gives me, 9 fifths times c equals f minus 32. I just got rid of the fraction by multiplying both sides by the inverse. And now to isolate that f, I'm going to work outside in. Well, the furthest number from f is this minus 32, so I treat it just like a plus 32. Just like any other equation, I move that 32 to the other side by changing its operation. 9 fifths times c plus 32 equals f. And so now if I was traveling in Europe, I would have a formula I could use to check my son's temperature. He was pretty hot, 39 degrees. You would just plug it in here and you'd be able to get his temperature in Fahrenheit. Well, he's still fine. He's fine now. So I guess all's well that ends well. So let's look at how we can do this. Let's learn how to rearrange an equation. So, my apologies. This got formatted poorly. Let's just move this one. Sorry about that. X plus y equals a. I'll put up here. Okay. Solve for the letter using inverse operations. So let's say I was going to solve for x plus 6 equals 7. We all are familiar with this. What would I do to undo what's with the x? I would subtract 6. And then I would have x equals, well, let's just write it out, 7 minus 6. That's what x is now equal to. I've moved the 6 to the other side by changing its sign. So how about if I wanted to solve for x here and I have an x plus y? Well, what would you do to undo what's with the x? You would subtract y from both sides. And so to get your answer, we would get x equals 7 minus y. We're doing just the same steps we do in equations, but now we're working just with letters that we move instead of numbers. Okay, so why don't you try this one? What if we have x plus y equals a, and I ask you to solve for x? Go ahead and solve, put that in terms of x. You should have subtracted y on both sides, but since we can't combine anything, we just do x equals a minus y. Done. Okay. And next, just carrying this on a tiny bit further. How would we solve for x on this problem? So you might write this a few different ways, but first I would work outside in. I'm going to work farther from x and add the y to both sides. But again, I can't just do 2 plus y. I don't know what that is. So I bring down what's left and I get 2x equals 2 plus y. But I'm not quite done. Is x isolated yet? No, it's not. How do I undo what's with x? Same as if I was solving, I would divide by 2 since 2 is multiplied here. And that means I'm going to divide this whole side by 2. Because if I divide one side by 2, I divide the other. And I get x is equal to 2 plus y over 2. That's my answer. Awesome. So it's time for you guys to try it. Now that we've gotten the hang of this, I want you to try. Oh, let's look at a big, ugly one together. So what if I asked you to solve for A? You're going to go through the steps in the problems that follow. So work outside in, go farthest from the A, think of what is grouped with A, and start undoing things step by step. What's your first step? Your first step should have been to subtract D, because D is the furthest thing. That's our outside in number. So I'm going to subtract D from both sides. And again, since I can't combine anything, I rewrite A minus B over C equals E minus D. Getting a little better. We're getting closer to A. Okay, what's your next thing to undo? Think of what is outside in from A. What is the furthest thing from A on its side? We should have seen that A is with the minus B here, but divided by C is our outside in number. So what we're going to do is we're going to multiply by, it wants me to restart this problem. I'm going to have to hold on, and I'm going to have to get back to where we were. My bad. There we are. All right. So to remove the divided by C here, we're going to undo it with a multiply by C times C. And we're going to do that on both sides, but I can't just put the times C on the end here. It needs to multiply the whole side by C. So I would write this. All right, cross that off. So our second step was multiply by C on each side. That was step 2. Now step 3. We're now left at A minus B equals E minus D times C. We could move this to the front because normally if it's multiplying by parentheses, we see the letter or the number in front of the parentheses. So I'm going to put it there. How do we isolate the A with our final step? You should add B on both sides. And there it is. We did a big, ugly problem. We add B on both sides. Again, I can't really do anything. I can't put it in the inside here. So I just get A equals C times the quantity E minus D and the quantity plus B. We've rearranged a large, ugly problem. Now it's time for you to practice. I will go quickly through the answers here. So I ask you guys to practice each one. Problem 1, you're solving for Y. Go ahead and begin. Type your answer. Or, I don't know how I have you solve it yet. I haven't made the ed puzzle yet. Okay, you should have added 2x to both sides. And so we get y is equal to 15 plus 2x. Problem 2, solve for y. How do we undo this? Oh, it's positive 4x, so I'm going to subtract 4x. And I get y is equal to 2 minus 4x. Okay, solve for y in problem 3. Oh, y is on the right-hand side. Well, that means I need to first undo the 8. It's minus 8. And I can actually combine these like terms. 5x minus 10 equals 5y. And next I'm going to divide by a 5 here. So I get y is equal to, now I could simplify this. If you left your answer as 5x minus 10 over 5, if I was grading it on a test, I'd probably take off half a point for simplifying. Notice both of these can be divided by 5, so we could get x minus 2 here as our answer. But if you stopped one step early, that's fine. Okay, next one, problem 4, solve for y. Should have subtracted x and gotten y is equal to 11 minus x, or negative x plus 11. Next one, solve for y here on 5. Okay, you should have subtracted 3x from both sides since it was positive, and gotten minus y equals negative 3x plus minus 4. And now I'm going to remove this negative by dividing by a negative 1. That would reverse both of those signs and give us 3x plus 4. If you're a little rusty there on dividing by a negative, notice dividing by a negative 1, you're changing the sign of everything, or you can times each side by a negative 1. Okay, last one, solve for y. You should have subtracted 7 and got 3x minus 6 equals negative 4y. Okay. And from here, we would divide by negative 4, and we get y equals, this negative sign can go now out front, but it's fine if you left it on the bottom, 3x minus 6 over 4. Or you can leave it on the bottom. It's fine either way. Okay, 2 final problems to practice. Actually 3, sorry. Solve on 13 and 14. So now we're actually looking at a formula. The first one, notice that 1/2 is multiplied by base times height. That's the formula for area of a triangle, and we want to solve for base. So first undo the 1/2, then undo the h, but it's 1/2 times base times height. Okay, what you should do here is get area equals 1/2 base times height. And to undo the 1/2, well, how are we going to undo it? I'm going to multiply by that reciprocal. We learned that in the weird problems lessons earlier. 2 over 1 is the reciprocal. And now I've got 2, well, 2 over 1 is just 2. 2a, 2 times a, equals base times height. Final step, to solve for base, I need to undo the times height. I divide by h. Both sides, whenever you divide one side, you divide the whole other side by h. And so you should get 2a over h equals base. So now, basically, if you've always got the base and you needed to plug it in, you would have a formula for that. How about this one? A little bit tougher, but very similar. Solve for the height from the volume of a cone formula. It's just like the last one. Okay, so what we're going to do is first, let me rewrite the problem. All of these are being multiplied. 1/3 times pi r squared times height. So first I'm going to undo the fraction by multiplying both sides by 3 over 1. Bring it down. 3v equals pi r squared. Height. We're missing the 1/3 now. Well, pi is being multiplied by height and by r squared. They're all being multiplied here, so the last step is just division of each time. I'm going to divide by pi on both sides. And we can just leave it like that. We don't need to change the number at all. 3v over pi equals r squared times height. And my final step is going to be to divide by r squared. Divide all of this by r squared. That looks a little bit ugly. Height equals 3v over pi divided by r squared. Let me go ahead and do a keep change flip here. Sorry, scratch that. Let me just teach you the easiest way to do this. Pretend I hadn't done all this. The easiest way to do this is to, when you're dividing by pi, you can divide by 2 things at the same time. Divide by the r squared as well right here. I'm going to cross that out and divide by the r squared on both sides at the same time. The other way, it just takes a little longer. I get height equals 3v over pi r squared. That is the equation for the height. So if you have several things being multiplied, like if you have d equals a times b times c, and you want to solve for c, you can divide by ab, and both sides ab, because both are being multiplied. You can divide by both at once and get rid of them both. Okay? All right, our final problem for today. Because I know something similar is on the test, I want you to solve for a here. You've got one extra step to do because a is on both sides of the equation. Go ahead and try it. Okay, what we should do is first move a to one side so that we can collect like terms. We want to go ahead and subtract a the same way we would otherwise. And remember, that is a 1a. So we're going to do 3 minus 1 is 2a minus b equals 14. Next, we're going to move outside in. We want to isolate the a. Add b to both sides and get 2a equals 14 plus b. And last, divide by 2. A is going to be equal to 14 plus b over 2. Okay. All right, guys, I thank your minds and your hearts. I thank you for your hard work today, and I wish you a good afternoon.